Hi there, I'm Kathleen Jasper, and today we're working on Math 5161, which is for the Praxis exam. This is going to be a more advanced video where we work through logarithms, which is going to be a little bit of calculus and a little bit of algebra. We're also going to go through some complex probability, and we're going to end the video with some trig functions. Let's get started. All right, so we are getting into the more advanced part of this exam, and I really appreciate all the feedback we've been getting. Feedback is welcome. In fact, I've gone to some other math YouTube channels, and people are ruthless on those math YouTube videos. They put in the comments all kinds of mean things to the teacher who's teaching. So I really appreciate how kind you guys are being on these videos. Again, remember, this is not my content area at all, but what I am trying to do is show you what's on the exam and give you a way to solve these problems quickly in order to pass this exam. So again, not a math expert. All feedback is welcome, and many of you have provided feedback in the comments that have actually helped me and will help our viewers. So please feel free to do that. And also, if you have any kind of tips or anything like that, feel free to email me at info@navaed.com and let me know if there's something I can change or do better, because again, not my content area. And thank you for being kind, because I have seen people just get eviscerated on their YouTube channels for doing math. The math crowd is a tough crowd, so I appreciate your patience. Today, I'm going to go through some problems that a person who views our YouTube channel sent into us. I changed them a little bit because they weren't my questions, and I don't want to copy anybody else's questions, but they're basically the same questions, just with different values and a little bit of different scenarios here. And we're going to get right into it right now. So let's take a look at my screen here. We'll start with number one. We're going to do 5 problems today. And again, remember, the problems are linked up in the description below. So if you want to work those out before you watch the rest of the video, you can go ahead and stop the video and download them there. Also in the description below are going to be some resources like properties of logarithms and unit circle, which we'll get to towards the end of this video. All right, so make sure you check out the description for all the resources there. Now, here we go with number one. Let's take a look at my screen here. You can see that if 7 to the x power equals 16, which of the following cannot be the solution to the equation? Now, you know that I always like to look at my answer choices before I do anything. This will tell us a lot about what's expected of us in this problem. Now, right away, I'm having a panic attack because I see the word log and I see ln and things that I'm not familiar with, right? So this is actually not too complicated of a problem, but we want to break down logarithms here so you can see how this works. Now, logarithms, when you see this log here, those are just another way of writing exponents. And the way you do this in the log equation, I guess you would say, or the way logs are represented, the way you do it is it's log and then your base, and then times c equals a. That's kind of the formula you want to use to plug in here. Now, the base is the base of the exponent. So in this case, 7 is the base. If this were, 22 to the x or 22 to the third, the base is going to be 22. It's that base number below the exponent. You just go ahead and erase that. So that's one way to figure that out. Now, if there is no base with logarithms, like let's say you're not given the 7, logarithms, the base is implied that it's always 10. But in this case, we do have a base of 7. So if I were going to write this, I would go log base 7. Now, c is actually what comes after the equal sign. So this is b, the x is a, and 16 is actually c. So this would be written as log 7, 16, and then this would be equals x in this case. Well, they're not showing the equals x there. So we know right away that a could be a solution because it's written correctly here, right? So if A could be, I'm not going to choose it. I'm going to check it just so you know that A could be a solution to this equation, but I'm looking for cannot. So I'm looking for the wrong answer essentially here. So A could be it, so I'm not going to pick it, and I can see why because of this here. Now let's talk about the other ones here. Now, another way of writing this here based on natural logs and the properties of logs. And again, I'm going to encourage you to go to the description to go look up the properties of logs. I'm not going to go through all the properties here because I'm just trying to get through this question as quickly as possible. But just know that you can rewrite this here as log 16 over log 7. All right, you can do that, log 16 over log 7. And again, it's part of the properties of logarithms here. So we can see that D would also be a way that we could write this equation or would be a solution to the equation. All right. Now, another way to write log 16 over log 7 is also natural log, which is ln 16 over natural log 7. That also works. So C could also be a solution. Therefore, I'm not going to choose it because I'm looking for the one that cannot be a solution. And that leaves B as the answer because it is not a solution. And here's why. Let's take a look at natural log 16 over natural log 7. That is a way to write this. However, if we look at B, natural log 16 over 7 is actually, and let me just get my calculator here, 16 divided by 7 is 2.29 if I'm going to round up. So this is actually natural log 2.29, and that is not the same thing as A, C, and D. So B is going to be my correct answer here because this is not correct, and that's how you would work through that. All right, now I'm going to do a word problem using this same kind of situation so you can see it done a different way. Let's take a look at number 2 here. Now again, I'm going to look at my answer choices here, and you can see I have percentages. Doesn't tell me much. Let's read the question stem. With that in mind, an earthquake that measures 6.9 on the Richter scale has a magnitude that is approximately what percent of an earthquake measuring 6.5? Okay, I still don't know what I'm talking about here, so let's read the whole thing. An earthquake measuring 7 is 10 times as strong as an earthquake measuring 6. That's why the Richter scale is a base 10 logarithmic scale. Remember I told you that base 10 is like the default for logarithms, okay? So the Richter scale is a base 10 logarithmic scale. And again, that's because a Richter scale of a 7 and a Richter scale of a 6, the 7 is 10 times as strong. So it goes in increments of 10. With that in mind, an earthquake that measures 6.9 on the Richter scale has a magnitude that is approximately what percent of a 6.5. All right, now I got this from one of the ETS practice tests. I did change it up a little bit so that it isn't exactly the same, but I really liked this one and I couldn't really write one of these on my own because I don't have the knowledge of logarithms to write like an awesome word problem using them. So I really liked this one. I did change it up a little bit. It is not exactly the same, but it has the same type of theme. And again, we're using those basic skills we did in question number 1 to work on this question here, question number 2. So we want to look and see what the Richter scale of the first one minus the Richter scale of the second earthquake. And in this case, it would be 6.9 minus 6.5, right? Because this one right here is the first one, and this one right here is the second one. And when we get that, we get 0.4, all right? That is the magnitude or the difference in magnitude here. Now, if we're going to write this in our logarithm, remember, 10 is the base. Now, this 0.4 here is actually A, because what we're saying here is 0.4 equals log 10, and we're doing the magnitude of A minus the magnitude of B, okay? Or you could do Richter A minus Richter B, but we're going to do magnitude A minus magnitude B here. Now, when we set that up, you can see that this 0.4 is after the equal sign or equals 0.4. When we do that, we know that log base times C equals A. So A is actually 0.4. Well, when we're talking about it in exponential terms, A is actually the exponent for B. So this becomes 10 to the 0.4 equals MA over MB. Why did I switch MA over MB when this is minus here? Well, the thing is the property of logarithms tells me I can do that. When you subtract logarithms, you can actually divide, similar to exponents. When you divide exponents, you're actually subtracting them. That's one of the properties of logarithms. So again, I want to encourage you to go into the description and look through those properties of logarithms. On the exam, you'll probably be given simple ones like this, where it's either addition, which you multiply the logarithm, or subtraction, where you divide. In this case, we can divide here. Now, look, all I need is this here, 10 to the 0.4. And I can go ahead and do that in my calculator here. And if I say 10 to the 0.4 exponent, I get 2.51, and I'll just round to 2.51. Well, how do I make that into a percent? Because these are all in percentages here. Well, I move the decimal 2, right? Because it's 100s. So I put it there. So this becomes 2.51%. All right, so let's take a look at number 3. This is a probability question, and this seems like a complicated question because you're looking at 2 pairs of dice, and it's not your standard probability, but it's actually quite simple. So number 3 says, what is the probability of rolling 2 standard dice where the sum is 7? Well, this stands out to me. Of course, I'm always looking for keywords, and I'm looking for my answer choices. I can see they're in fraction or ratio form. And so in this case, we want to make sure that we are using our probability skills. So we have 2 standard dice where the sum is 7. Now, this is actually a question about craps. So if you are a fan of the casino and you like to play craps, my husband loves to play craps. This is why 7 is craps, because 7 has the best probability for the house to win. Let me show you why. What are all the ways in which I can roll a 7? I have 2 dice in my hand. I throw them. What are all the ways I can roll a 7? Well, I can roll a 1 and a 6, right? I can roll a 2 and a 5. I can roll a 3 and a 4. Well, I can also roll a 4 and a 3, a 5 and a 2, and a 6 and a 1, right? Because this is all the ways in which I can do that. And so if I were to count that, it'd be 1, 2, 3, 4, 5, 6 different ways that I can do that. Now, that's why 7 is craps, because this is actually a lot of possibilities to roll a 7, and that's why the house wins on a 7. Just a little side note there. So these are all the ways. So there are actually 6 ways out of what are the total ways in which you can do that. All right, so let me draw my dice here. 1, 2, 3, 1, 2, 3. These are terrible looking dice, but 1, 2, 3, 1, 2, 3, right? So there are 6 possibilities of 6 when we're talking about a pair of dice. So that's going to be 6 over 6 times 6, which equals 6 over 36, which can be reduced to 1/6. In the casino, you have a 1 in 6 chance, which is a pretty good chance, of rolling craps, which means the house takes your money. So the answer to number 3 is A, 1/6. Okay, now let's take a look at expansion here. Now, you might get a question about expansion on the test where either you have to choose A, B, C, or D, or there may be some areas in the equation that they want you to fill in. So I'm going to show you how to do that today. There are a couple of ways to expand this quantity or expression here. However, I prefer to use Pascal's triangle. Now, let me just show you what you could do. You could say x plus y squared, x plus y squared, and then you could FOIL that out and get your coefficients there. However, I would prefer in this situation to use Pascal's triangle because you're probably going to be asked to fill in the coefficients here. I'm going to show you what that looks like at the end. Now, Pascal's triangle is something very easy to use. It has a pattern, and I'm a fan of patterns here. So what we're going to do is we're going to the 4th power here. And so what I want to do is use Pascal's triangle to go to the 4. So x to the 0, let's start there. X to the 0 equals 1, right? And then we have x to the 1. We're going to start and end with 1. With Pascal's triangle, we start with 1 at the top, like at the top of the Christmas tree. And then on Pascal's triangle, there are always going to be 1s on the ends. You're going to see how that works out in a second here, okay? Now, x to the second, remember I'm always going to start with 1, but I'm going to add these two numbers here. It's going to be 2, and this is going to be 1. X to the third, I'm going to start with 1. I'm going to add these two, which is 3. I'm going to add these two, which is 3, and I'm going to end with 1. X to the fourth, bringing it out a little bit more, I'm going to start with 1. I'm going to add these two. I get a 4, I get a 6, I get a 4, and again, I'm stopping with a 1. And let's just take it out one more time just to get the pattern, even though we only have to go to here. But let's just do one more, x to the fifth. We're going to start with 1. We're going to add this. It's going to be a 5. We're going to add this as a 10. We're going to add this as a 10. We're going to add this as a 5. And we're going to end with a 1. So hopefully you see the pattern there. And this can go on and on and on all the way to infinity. Now, these are the coefficients. So these are the coefficients I'm going to want to use because I'm doing x to the fourth here. So my coefficients for this expansion are going to be 1, 4, 6, 4, and 1. Now remember, coefficients are what go in front of the variable here. Okay, so this is a coefficient. Now, beyond just the coefficients, I have to figure out what the x and the y is represented in this expansion here. And so what I'm going to do is I'm going to figure out all the ways in which I can get the exponent of 4. And so I can do that a couple of ways. And I'm going to leave some space in my expansion to add in my coefficients. So let's just go here. So one way I can do this is x to the 4, y to the 0. Because remember, to get an exponent here, we're adding exponents. So x to the 4, y to the 0 is x plus y to the 4. All right. Now I'm going to put my plus sign here, and I'm going to leave some space here. Now I know we typically don't write y to the 0. I'm going to fix all of this up in a minute, but I just want to show you the long way so you understand what's going on here. I'm going to leave a little space because I need room for a coefficient there. What's another way I can write x plus y to the fourth? So it's going to be x to the third, y to the 1. Now again, I know we don't write y to the 1, but I just want to leave it there for a second. I'm going to put a plus sign here. Now, these are all going to be plus signs because this is a plus sign. If this were a minus, it would be plus, minus, plus, minus, plus, minus, alternating all the way down, okay? But in this case, we're lucky it's a plus sign. I don't have to deal with that. It's going to be plus signs all the way down. So how else can I get x plus y to the fourth? Well, I can do x to the 2, y to the 2, right? Because those two exponents, when added together, equal 4. And I can also do x to the 1, y to the 3. And I can also do, we're going to put a plus sign here, x to the 0, y to the 4. All right? Now, I want to clean this up because we don't do y to the 0 and x to the 0 and y to the 1 and all of that. We want to clean that up, and I'm going to add my coefficients. So in this case, y to the 0, anything to the 0 power is 1. So I could essentially just do x to the fourth here because x to the fourth times 1 is just 1. So I'm going to leave that. Plus, and I'm going to still leave space for my coefficients. I'm not done yet. X to the third, y, because anything to the 1 power is itself. So this is x to the third, y. Put a plus sign here, leave a little bit. This is going to be x to the 2, y to the 2. Can't delete anything because both of those need to be there. Plus, and again, I have x to the 1 here. So this is just going to be x, y to the third. And then I have x to the 0 here, which is 1. I don't need to write that. I can just do y to the fourth. Now, on the exam, they might give you this whole thing down here. And they might ask you to fill in the coefficients. In fact, that's the way I've seen it on the exam. So let's fill in our coefficients. Now let's go back to our Pascal's triangle here. And I can see that my coefficients are going to be 1, 4, 6, 4, and then 1. Now, do we need the 1 here and the 1 here? No, we don't, because that just is x to the fourth and y to the fourth. We don't need that. So I can go ahead and eliminate those just like I eliminated the exponents we didn't have to write because you don't need it. So in this case, the expansion is x to the fourth plus 4x to the third y plus 6x squared y squared plus 4xy to the third plus y to the fourth. And you can see that my missing coefficients, I added them in here. 4, 6, 4. Again, we could put these ones on the ends, but we don't need to. This is the way you might see it on the test, or you might just have to pick the proper one in A, B, C, or D. Either way, this is a good way to do it. This is the way I like to do it. Again, you could FOIL x plus y squared, x plus y squared, but for me, Pascal's triangle plus, using the exponent rules here to expand your exponents works best for me. Hopefully you find that helpful. All right, so now we're going to get into something a little bit more complicated. We're going to be working with trig functions and also unit circle. Now, here is the kind of template, I guess you would say. Don't skewer me in the comments, but this is a unit circle, and this is going to be helpful for us as we work through this particular problem. This is included in the handouts in the description, so you'll be able to have this to help you work through this problem. All right, so let's take a look at this particular problem, number 5 here. What are the rectangular coordinates x comma y that correspond with the polar coordinates 2 pi over 3? All right, so we see this polar here, and we see this crazy coordinates there, all right? Now, we're going to be working with a bunch of different things. This question tests a couple of different things, but we're going to be using unit circle here. Now, the first thing we want to remember is x and y, when we're talking about polar coordinates, they represent or correspond with radius theta. And theta is the measure of the angle we're going to be working with. It'll become clear in a second here, okay? The other thing we're going to want to remember for this test is and I like to call it SOHCAHTOA, but my husband likes to say those are trig functions. It's not called SOHCAHTOA. Well, I like to call it SOHCAHTOA because it helps me remember my operations. So when we're talking about SOHCAHTOA, I like to write it like this. So is opposite over adjacent, so that's sine, S, sine. Ka is cosine, which is adjacent over hypotenuse. Toa, which is tangent, which is opposite over adjacent. Sorry about that. So it's SOHCAHTOA. This is sine, this is cosine, and this is tangent, all right? Again, trigonometry gives me heartburn, but we're going to get through it, don't worry. SOHCAHTOA. Now, those are the two main things you want to think about. You want to remember your trig functions, and you want to know that your polar coordinates correspond with radius theta here. Now, let's go ahead and draw my coordinate plane. I'm going to do the best I can, you guys. I am not a stellar drawer when it comes to this, but let's just try to draw our straight line here. So this is our y-axis, and let's go here for our x-axis. I'm always so impressed with Sal Khan on Khan Academy because he draws so well and his handwriting is so good, and mine is always so messy. But anyways, I'm learning to be better. So here's our coordinate plane because we're working with coordinates here. And if we're looking at 2 comma pi over 3, 2 is the radius, all right? So what I want to do is I want to go over 2. So here's 1 and here's 2, okay? When we talk about polar coordinates, we're actually talking about an arc or like a circle here. We know that this is the radius, right? Because the radius is 2, and that's right here because radius is the first number corresponding with x. So I can essentially draw my radius from any point on this circle here, because remember the radius comes from the center and goes out into the edge of the circle. Now, let's talk about theta here. Theta is the angle, which is this here. Now, when we talk about pi divided by 3, pi represents 180 degrees. So I'm essentially saying 180 divided by 3, which is 60. Now, if you need more clarification on that, let's go to our unit circle, and you can see here, pi over 3 is 60 degrees. Pi over 4 is 45 degrees, pi over 6. And you can see all the different ways in which the theta is represented here. We happen to be over here in this quadrant, but if we were like 2 pi over 3, we would be in this quadrant. If we were, 3 pi over 4, we would be over here. So just understand that this unit circle is going to show you where on the coordinate plane we're going to fall. And in this case, we're at pi over 3. They make it kind of easy for us, and they will make it sort of easy on the test. They're just kind of assessing these skills. We're going to be in this coordinate or quadrant here, right here. Okay, so let's go back to my crazy circle here. All right, so I know that this is going to be kind of an arc, and this is going to be 60 degrees, because remember, theta, which is this angle right here that we're talking about, theta is going to be 60 degrees. Now remember, this is 2, because my radius, no matter where I draw it out from, it's going to be 2, all right? So I have a couple of values here, and now I have to figure out how to do this. Now let me erase this, because I'm going to need this space to do some mathematics. And we already know that pi over 3 equals 60 based on our unit circle and the fact that pi represents 180. And if I take 180 and divide by 3, I get 60. All right, so now what we're trying to do is we're trying to figure out our rectangular coordinates here, which means our straight up x and y, not our polar coordinates. So when I do that, I want to draw this triangle here. And I know that this equals 180. So what I'm looking for here is this leg, which is my y, and this leg here, which is my x. Now, if theta is right down here, I'm looking for my opposite over hypotenuse because I have my hypotenuse here. My hypotenuse is 2. So if I have my hypotenuse and I'm looking for my opposite, I'm looking for opposite over hypotenuse for my y. So my y is actually going to be sine, right? Because sine is opposite over hypotenuse. So in this case, I'm going to have 60 sine 2. So my y is going to be 60, which is my theta right here. Sine, because I'm using sine because I need the opposite, but I have my hypotenuse. And it's going to be 2 because my hypotenuse is 2. All right. Now I'm going to use my calculator to figure that out, so don't worry about that. Now for my x here, I'm looking for this right here. Well, this is adjacent to theta because look, this is theta here, 60 degrees. And so this right here is my adjacent side. So I'm looking for adjacent, and I have my hypotenuse too. So I'm going to use cosine for x. I'm not going to use tangent. I don't need tangent here. So for x, I'm going to have 60 cosine 2. Now I can put that right in my calculator here, okay? So let's just figure that out. Let's figure out what x is, okay? So if I do 60 cosine, and I like to hit the equal sign just to make sure, I get 0.5 times 2, that equals 1. So on my xy, I'm getting a 1 there. Well, I can eliminate a, c, and d right away because the only one with the x coordinate as 1 is b. So I could choose b and move on, but let's just solve for y so that you can see. Let's figure out what our y coordinate is. Now let's use our calculator again. If I do 60 sine, I get 0.866025, whatever. I like to hit the equal sign. And then I hit times 2, I get 1.73, which is about the square roots of 3, right? Because the square root of 4 is 2, right? So the square root of 3 is going to be somewhere between or a little bit below that. So I can safely say that it's the square root of 3. So I know I can estimate and say B is my answer there. Now, be careful. When I first did this question, I chose C. And remember, a good math test is going to use your wrong answers here. And because what I tried to do is make this a 30, 60, 90 triangle and then just figure out the legs of that triangle. But that's not enough because we're looking for the coordinates. And so C would be wrong because we're not just using a 30, 60, 90 triangle. We actually need to go into our trig functions and use our SOHCAHTOA here. All right. So that's how you would figure out this particular problem, number 5, when it comes to polar coordinates. All right. And remember, you're going to want to use this unit circle. You can actually kind of memorize these pretty well. Just remember that pi represents 180 degrees. So it doesn't matter. Let's say you're here, 7 pi over 6. Let's say that was your y coordinate. All right. Well, if it's your y coordinate, all you do is do 7 times 180, and you put that over 6, which would be 180 times 7 divided by 6. And you've got an angle of 210 degrees. Well, yeah, look, that's 210 degrees, right? So you can see where the angle measures work there when we are doing polar coordinates, which has to do with a circle on the coordinate plane. All right. All right, so hopefully this clears things up for you. Again, we got these questions from a person who watches our YouTube channel, which I was super grateful for because it's hard for me to come up with these questions because, again, this is not my content area. If I were coming up with social studies questions or science questions, I could easily, come up with a practice test. But this is really hard for me, and I want to make sure I'm doing the right thing. So if you have questions that you found in a textbook or maybe on a practice test, you can send them to us at info@navaed.com, info@navaed.com. And provided, we're not breaking any copyright or anything like that, we will go ahead and work them out for you on our YouTube channel. We always check copyright and make sure we may change the values like I did here for our problems. But it's a really good way to help me do this because if I have to create 10 problems or 5 problems every time, it takes me a lot longer. So if you're at home struggling with something, submit them to us and I will do my best to figure them out. This took me forever to figure out. Hopefully you guys got a lot out of it, but it was kind of fun because my husband and I were, up kind of working out math problems like 2 super nerds last night. But we're really trying to get through this 5161 for you. Today we hit a lot of different things, logarithms, trig functions, and probability all in one set, which is helpful. Now, I am working on derivatives. I promise. Many of you are asking for derivatives, but the thing is, I'm having to learn derivatives, and so it's taking me a little bit longer. I appreciate your patience. I promise I'm working on them. I just want to make sure that I'm representing them accurately and that I'm not giving any incorrect information because that would be bad, okay? So I really appreciate your patience. If you have any sample problems for derivatives you want to submit, please do that at info@navaed.com, and I'll be happy to take a look at those, and you'll actually be doing me a favor. Thank you so much for watching today. Be sure to comment below. Also, feel free to subscribe to our YouTube channel. Tell your friends and colleagues that we're here, and hit the notifications button so you get notified when we upload new content. Have an awesome day.